This lesson will be looking at writing an expression from a pattern. So if you're looking at what we have here, first of all, there's a typo on the screen. This should say term number, not team. I can't write very well with my finger, but it should say term number, not team. So we have the term number 1, 2, 3, 4, and the term in the sequence. So our pattern is 5, 8, 11, and 14. In order for a sequence to be an arithmetic sequence, it has to have a common difference. So we have to look at the terms. So our first two terms are 8 and 5. If we find the difference again means subtraction. Between those two, you get 8 minus 5, which is 3. The next two terms are 8 and 11. You find the difference there. 11 minus 8 is 3. And then the last two terms are 14 and 11, and again, their difference is 3. So this pattern or this sequence does have a common difference, which is 3. So you could be asked to find or to predict the term number for the term number that's given. So it wouldn't be so bad to continue the table and keep adding 3, say, to the 10th term. But if you look at the questions, it's asking you for the term number 7, 15, and 59. Those would be a very long way to extend the table. So when I did this in school, my algebra teacher just basically said, okay, find the pattern and write an expression. Well, I had no idea how to even begin to write an expression because I could look at it and say, okay, I don't know. So here's an easier way of writing the expression for the term term number to be able to find the term. So in order to do this, you want to take the common difference, which in our case is 3, right? So we want to take 3 and you want to multiply it always by 1 because we're looking at term number 1. So 3 times 1 is 3, right? But if you look at our table, in our table we didn't have 3 there, we had 5. So we needed to be able to take 3 and do something with it, either plus or minus something, to get to 5. In order to get to 5 from 3, because 5 is bigger than 3, I have to add. And I have to add what? I have to add 2, right? Because 3 plus 5 is 2. So to make my expression, which you can see here already is listed, 3n plus 2, I have to take my common difference, and where I multiplied it by 1, I'm going to replace or substitute that 1 with an n. So I have 3 times n, and then I added 2 to the 3 to get the 5. So I have plus 2. So my expression is 3n plus 2. Again, the 3 is my common difference. So 3 times 1 is 3. And I had really a 5 in the first line of the table. So I needed to get to 5, so I'd have to add the 2 to make 5. And it would work for every line in that table. So term number 2 is 8. So 3 times 2 is 6. Plus 2, again, gives you 8.